The last two questions that we're going to look at for this section are a couple of multiple choice type questions that you would see on the AP exam. And these actually come from previous AP exams. So the first one here, a particle moves in a straight line with velocity v of t meters per second, where t is time in seconds. At t equals 5, the particle's distance from the starting point was 6 meters. What is the total distance the particle has traveled? This key phrase right here tells you that you're going to have that absolute value aspect to your integral. And the only one with an absolute value is option C. So that one's pretty clear that the total distance is going to be the absolute value from 5 to 10 of that expression. But what do these other ones mean if you were to see it on a multiple choice portion of the test? Well, for option D here, this guy right here has no absolute value, so this is actually just the displacement from t equals 5 to t equals 10. If I look at option B right here, this one is just simply the position of the particle at t equals 10 seconds, because you're told that you're with the starting point of 6 meters, and then you're measuring your displacement from 6 meters. So where's the particle positioned in space at the end of 10 seconds? And then A right here, you're taking the velocity at time equals 5, and then adding 6 meters a second. That really has nothing to do with the problem whatsoever. So the key phrase that you see here is total distance, and that's where you got the absolute value aspect. The last one here is the second multiple choice problem, and this one you're asking for the particle's displacement. So you know this is a v of t function, and we can eliminate option C because that absolute value one is going to be, once again, total distance. And we can eliminate option D because this is going to be total distance plus 9 meters. That really doesn't give us a lot of information, specifically total distance, I should say, from t equals 2 to 9. Plus 9 meters. And as I look at between option A and B, the particle's displacement looks most like that from t equals 2 to 9. That extra 10 is just an extra 10 meters added to the displacement, which doesn't help us. So the displacement from 2 to 9 is going to be just v of t dt. And if you're not sure on some of these, head back to the page 18 that had all the expressions that are used for these particle motions.